Hi everyone. Today I am back with understanding modulus and its applications. Yeah, today we will solve three questions and this will be a very what you tell common concept for everyone. All of you, I hope you know this modulus function. It's nothing but modulus of minus 2 is 2 and of modulus of 2 is also 2, means we only find out the magnitude of the value, nothing else. So since it's a very easy topic and not many things to be discussed about it right now, I am making this is the first and the last video of this chapter. Today I will only uh, upload this video and make it the playlist also, since it's the first as well as the last. No more video will be made up to now. If I get more questions about modulus function, I will surely come back with this, with the title of this thing 2.0. That's we will surely come back, not now. Hope for it afterwards. Today I will do a very little theory which we need to focus before starting on the questions. We have, as usual in all of my videos, three questions: first one, second one and the third one. With this I hope that we will complete the full modulus function at a glance. First one will be very easy, second one will be a little moderate question, and third will be a lengthy question but conceptual, very easy to be thought about. Let's start with our theory. Today, what's the modulus function? First, it's a modulus function. Let me tell you, this is a function. Modulus means a function here. Means it can be written as a form of f of x, right? Let's write the function. What is it actually? The function is. This type of function is written like this. Since it's not a one equation function, as we can tell, it's have two forms for different values of x. That is, for x greater than 0, a value will be x only, f of x will be x, and for value less than 0, f of x will be minus x. Easy to think about the graph now. No need to give it a bracket here. Let me rub it. Yeah, this is the wrapping it. Yeah, this is the function. Let's draw a graph. I'm drawing it here. Pausing for. Yeah, I'm back with the graph. This is the graph. This is something the graph will look like. If this is the value 1 here, this will also be 1 here. This 1 here, and 2 again 2 here. Then 3 again 3 here. This is the value as it goes on. Here minus 1, it will go to be 1. Here minus 2, it will be 2. Here minus 3, can't draw now, but it will be minus 3. This will be minus 1. This is minus 2. This is 2, then 3. Then here it's 1. This is 2. This is 3. Nice. This is how the graph will look like. Nothing will be moved to the negative side. The curve will not move to the negative side. The 0 value will be 0. Modulus of 0 is 0. Then we can write this as greater than equals to only. Nothing to, or less than equals to. 0 is a very weird thing in modulus. Let's talk about a basic thing which we need to use while solving equations of modulus. If we take equation like mod of x equals to 2, if mod of x is equals to 2, then we will write it as x equals to plus minus 2. This is what the basic thing we need to know while solving questions on modulus. Moving on to the first question. Oh, it's moving up. Yeah, what happened? Yeah, slide number will change. Here is review, and I'm starting inking. Yeah, this is the question. Mod of x minus 1 is 4. Very simple question. Mod of x minus 1 is 4. Nothing to be told about also. Try this question. I will not give you any options here. You will only check the answers. No option to be given also. By the way, starting with the solution. Pause the video and solve it yourself. I am starting with the solution. Answer is nothing but what, 5 or minus 3. It is so simple that one can only put the values and check where this will be holding. But since there is a formality, we need to solve this question. It's x minus 1 modulus is equals to 4. Then we will write this as x minus 1 is equals to plus minus 4. Every equation can be solved in this way only. In some equation we need some logic also while solving. But here I don't think we need any logic, or if you think of logics here, we can write x minus 1 will be 4 when x minus 1 is greater than 0. Then we will write this as x minus 1 equals to 4 condition x minus 1 is greater than 0 or x is greater than 1. This is the condition to be held here, and we will find x equals to 5, and this condition will fairly hold in this place. So 5 is the correct answer. 5 is already got. Then we can write x minus 1 is equals to minus 4 when x is less than 1. I'm not writing equals here. If x is equals to 1, nothing to be told about. If x is equals to 1, it can't be 4 only. So x equals to 1 is not a condition at all. I am not thinking of a condition here. We will find x equals to minus 3, which again fairly holds. Minus 3 is again fairly less than 1. So minus 3 is fairly holding. In some question, this condition will not so easily hold. So it's advisable to think of this condition every time. Like in our question number 3, it will not hold here in question number 3 like this if we don't check the conditions. Moving on to the second question. Try this out now. It's also a simple question, a little higher than the first question. Second question, mod of 3x minus 2 plus x is equals to 1. 11, sorry, it's 11. Yeah, solve it. I'm moving on to the solutions. Answer is 13 by 4 or minus 9 by 2. Let me check. This must be the answer. Moving on to the solution part. 3x minus 2, mod of this is nothing but, here it's nothing but, this thing came out as a tail. Yeah, this eraser, I'm rubbing it. Yeah, now it seems to be very nice looking. This is 11 minus x. Solving this, 3x minus 2 is plus minus 11 minus x. See, answer will come again simply. For x greater than 3 by 2, writing for x greater, sorry, not 3 by 2, it will be 2 by 3. X greater than 2 by 3, 3x minus 2 will be 11 minus will be equals to 11 minus x. Yeah, it seems to be h sometimes. Just mouse was not one. Yeah, I'm back. It's 11 minus x. Solve the equation. It will come here 4x and here 13. And this will be implies not equals to. This implies x equals to 13 by 4, which is again fairly greater than 2 by 3. So again, no worrying here. As I told you, worrying will be in case of question number 3. That's the ultimate question. With this, we will learn full modulus applications, everything in the third question. It's such a question. Many branches of the question will come out while solving. Leave while we solve, we will get it. X less than 2 by 3, checking. If x less than 2 by 3, then it will be 3x minus 2 is equals to, I am not doing modular inequations here, because modulus inequations are there, but they are not so called important, and that's also easy. There is a trick there also, I will tell you at the last. If you, yes, I will tell you. Here there is one condition here, leave. Here it will be minus 9 by 2, again fairly, leave. This is a big equals to sign here. It's minus 9 by 2, again fairly less than 2 by 3. Then these two are already satisfying. Done. With this way, move to the third question. See the third question. It's, you can find it seem to be easy question, but not so, because many conditions and branches will come out of this question. Since there are two two modulus functions here. Before this question, let me tell you what I was going to tell. For solving any inequations with modulus, let modulus of x is less than 2. We will check it only like this, that plus minus of x we will take here. There we would take on the RHS, here we will take it LHS. Then it will come to be x less than 2 or greater than minus 2. Right? On giving minus there, we will only change this sign, and this is a separate thing, not any using this question. This question is talking only about questions on modulus equations, not inequations. Inequations, this is the trick we need to follow while solving so-called modulus inequations. This is the question. A mod of x minus mod of x minus 2 is equals to 2. Find the value of x. Solve for x. Anything. Big question, needs very much attention. Pause the video. Think about for more than 5 to 6 minutes. Then come back with this, our answer. Answer will be all real values greater than equals to 2. All real values. Yeah, that's the one very humorous thing, that we can find it easily only thinking about if we use trial and error method or anything, that only checking the values. Because if it is less than 2, this will be negative, this will be negative, and it's not coming. But if we are going to solve it by our primitive main method, which is taking plus minus on the RHS, it will be a very long trick. I will show you the full process here. This is the equation. We will take mod x on the only and the remaining part in the RHS, mod x in the LHS. 2 plus mod of x minus 2 mod of x minus 2. Mod of x can be written as plus minus here, taking plus and minus, that is 2 plus x minus 2. Here is another mod. So 4 conditions will arise from here. You will see. For x greater than 0. If x is greater than 0, plus condition will hold. Then x equals to, I think we will not be able to fit in this page. I will rub some portion from this page. Then this is the thing. We will write x minus 2 mod is equals to x minus 2. This form of thing is a concept. We will solve this type of things conceptually. Why this sort of things arise? See. Now again another condition for a branch of the big condition, that is for x greater than 0. For x greater than 0, we take x greater than 2. This is another condition, greater than or greater than equals to 2. Here we will think about equals everywhere. See what will happen. For x greater than 2 or greater than equals to 2, we will get x minus 2 is equals to x minus 2. Yeah, what is this? Everything will come cut, answer will be 0 equals to 0. This simply means nothing. Many people get confused. We can 0 is equal to 0, then what's the use? There's many use of this statement. It only tells you that for all x greater than equals to 2, the value will hold. For all x greater than equals to 2, it is true. It is true. Now we can now see for x less than equals to 2. Less than 2, not equals to, we will take less than 2. Right, now this will be 2 minus x. 2 minus x equals to x minus 2. We will solving to 2x equals to 4, x equals to 2. X equals to 2, but the condition we have taken here is x less than 2, and 2 does not belong to a set. So no use of this statement. No use. No solution came from here. From here no solution. Now this part is done for x greater than 0. Rubbing that part, modulus in equations. Hope you have noted that. Yeah. Come back to my pen. This was 2, I have left it here again. And there is a bracket open. Yeah. This was the process. Now, for x less than 0, again say similar thing will arise. X will be equals to minus 2 minus x minus 2. X minus 2. This will be the condition. Solve again. This will be x plus 2. Wait, this way here it will remain x minus 2, and I can write this here as minus 2 minus x. It will make the question simpler. Yeah. Again for x greater than equals to 2, another sub condition. No, we can't take x greater than equals to 2 here. No need of taking, because we have already taken x less than 0. So for x greater than 2, no need. I am writing direct for x less than equals to 2. Less than equals to or less than 2? Less than 2. Here was the question. For x less than 2, check the condition, it will come x minus 2. X minus 2 is, yes, it will come x minus 2 is equals to x plus 2. Minus will go there and it will come x plus 2. See, this will be a very weird sort of thing. It will come minus 2 is equals to 2. Impossible to hold. So this again simply means nothing but there is no solution in this set. We have no solution in this set. No solution in this set. So final. Here no solution. Here no solution. And another thing, for x greater than equals to 2, it will not hold with this. So no need to check it. Only 3 conditions arise. Out of these 2 gave only no solutions. Only one was the thing which only gave the solution, which was x greater than equals to 2. So our answer was x greater than equals to 2. With this I am ending the video and the chapter here. Thank you.